Welcome to White Paper Podcasts, where our hosts Andre and Heather discuss a wide variety of informational sources, making them easy to understand in a fun and entertaining way.
Imagine hiring a sous chef and, instead of them just handing you the raw ingredients to cook, they actually prepare an entire 5-course meal. They plate it perfectly, and they only pause to ask you to, taste the sauce before it goes out to the dining room.
Right, which would be amazing, obviously.
Oh, totally. Well, today we're looking at empirical data proving that artificial intelligence has officially made that exact transition. It's gone from gathering our ingredients to actually cooking our meals. We're diving into a newly released, highly detailed study from June 8th, 2026.
Conducted by Perplexity along with researchers from Harvard Business School, right?
Yeah, exactly. They analyzed the real-world deployment of Perplexity's computer system. That's a general-purpose agent orchestrator they launched earlier this year in February. And they basically put it head-to-head against their traditional conversational assistant, which is just known as Search.
Which really makes this a crucial moment for, well, anyone whose job involves looking at a screen. I mean, for years, economists have just relied on these theoretical models about the exposure of jobs to AI. We've all seen the heat maps and the charts predicting what might be automated someday.
Oh, yeah, constantly.
Right. But this study completely abandons the theoretical. It gives us hard empirical data on realized task recomposition. It tracks what actual users are doing in their daily workflows right now.
Which is so valuable. So our mission for this deep dive is to uncover exactly how this leap from, a basic assistant to an autonomous agent is fundamentally rewiring knowledge work. It's saving staggering amounts of time and essentially transforming the everyday worker from an operator into a supervisor.
Yeah, and to really understand how work is changing for you on the ground, we have to look under the hood at the mechanics here. The most glaring difference in the data is what we might call the autonomy.
The autonomy leap.
Yeah, it's the shift from a machine working for a few seconds to a machine working for, well, close to half an hour.
Okay, let's break that down. Because with the traditional search assistant, the interaction is pretty transactional, right? You ask a question, and the system returns an answer in what was the average.
About 33 seconds of machine execution. It's a rapid retrieval mechanism.
Which is exactly what we're conditioned to expect. You type a query, you get a synthesis almost instantly.
Right, but the architecture of computer operates on a completely different time horizon. Across the 10,000 matched pairs of queries they analyzed, computer performs an average of 26 minutes of machine execution per session.
Wait, 26 minutes of continuous compute time from just one single prompt?
Yep.
That is a massive escalation.
It's a 48 times increase in machine work on effectively the exact same tasks. And, while the median is 9 minutes, that 26-minute average exists because there's this long tail of highly complex requests where the system is just grinding away for an hour or more.
Wow. But what is it actually doing for an hour? It can't just be generating text.
Oh, no, definitely not. It's searching, browsing, writing code, editing, running the code, encountering errors, debugging those errors, and checking its intermediate results.
So it's actively interacting with the outside world.
Actively interacting, yeah. The study tracked how often these systems interact with external connected services. Computer averages about 1.19 connector calls per session compared to Search's 0.10. So that's a 12 times ratio.
It's a huge jump.
It is. It relies on API endpoints and a framework called the Model Context Protocol, or MCP.
Oh, let's talk about MCP, because that sounds like a super dry technical term, but it's really the secret sauce here.
Totally.
Think of MCP as a universal digital skeleton key. Instead of the AI just sitting in a chat window reading a static spreadsheet you uploaded, MCP lets it actively unlock your email client, pull a specific contact, check your calendar, cross-reference the dates, and then draft an itinerary in a completely separate app.
Right. It translates the data seamlessly between programs.
Exactly. It's the difference between driving a manual transmission where you have to shift all the gears yourself versus setting a destination in a self-driving car that just navigates all the API traffic for you.
And that mechanism is exactly why that 26 minutes of execution time is so productive. It basically has the keys to traverse your whole digital workspace.
Hold on, though. 26 minutes of unsupervised machine execution just wandering through my apps sounds terrifying. I mean, if I leave a standard chatbot alone for 2 minutes, it sometimes completely hallucinates a fake legal precedent or loses the thread entirely.
Right.
So how are they preventing a system running for half an hour from just creating an absolute disaster?
Well, what's fascinating here is that the exact opposite is true. You'd logically expect that letting an AI run wild for that long would cause user frustration to skyrocket. But the data shows a 55% drop in next turn dissatisfaction.
Wait, really? Dissatisfaction drop?
Yeah, it fell from 2.9% with search down to just 1.3% with computer.
How does doing 48 times more work behind the scenes result in fewer mistakes? That doesn't seem to make sense.
Because the autonomy is structured, you know? The system isn't running blind. The researchers found a really crucial mechanism. Computer pauses for user input 13% of the time, compared to just 0.3% for search.
Okay, so this is the sous chef tapping me on the shoulder to taste the sauce before serving the dish.
Precisely. It actively uses pause for user tools. When it hits a point of ambiguity, it stops to request approval or ask a clarifying question before it moves on.
Oh, it's smart.
Yeah, and this built-in checkpoint system fundamentally shifts the psychological role of the human in the loop. With the old search assistant, users are trapped in these short digest and execute loops.
Right. The AI gives you a nugget of info, you mentally digest it, and then you have to go actually execute the work manually in your software, which means the burden of momentum is entirely on me.
Exactly. But with computer, users enter into longer review and extend loops. The system does all the heavy lifting, navigates the APIs, writes the report, and presents you with a highly developed draft.
And your cognitive load completely shifts. You're just reviewing the output, correcting course, and asking for extensions. You officially move from the execution layer to the editorial layer.
Yes.
Because the machine is doing the execution, I'm not, burning my mental energy figuring out the syntax of an Excel formula. I'm just looking at the result and deciding if it works.
Right, which leads directly to the next massive finding in this study. Because if an agent is handling that 26-minute grind of execution, what happens to your schedule and the company's bottom line?
The efficiency shock.
The efficiency shock is staggering. The researchers designed a really rigorous comparison between two workflows on the exact same tasks. Workflow A is the traditional paradigm search plus human execution. The AI helps gather the research, but you do the actual mechanical work.
Okay, and workflow B?
Workflow B is the new paradigm computer plus human review. The agent does the mechanical work, and the human just scopes the project and reviews the output.
So what does that delta actually look like in real hours?
Average task time dropped by 87%.
Wow.
Yeah, it plummeted from an average of 269 minutes down to just 36 minutes.
We're talking about taking a task that eats up half of your standard workday and reducing it to a little over half an hour. That's life-changing.
And the financial implications are profound. They mapped those time reductions against the May 2025 BLS wage data to calculate the monetary value of that saved time.
Okay, and what did they find?
The cost of completing an average task dropped by 94%.
A 94% cost reduction across the board.
Across the board. But with massive spikes in specific domains, programming is the absolute most extreme outlier. Yeah. A coding task that traditionally took 596 minutes, which is essentially a grueling 10-hour day of manual coding and debugging, was completed in just 48 minutes using the computer workflow.
Wow.
That's a 92% reduction in time and a 96% reduction in cost.
Okay, let's unpack this methodology because I'm looking at a 96% cost reduction and an 87% time reduction. And as a natural skeptic, my alarm bells are ringing.
Sure. Yeah.
How do they even know how long a human would have taken if they didn't literally sit behind thousands of users with a stopwatch measuring their workflow?
Well, they actually anticipated that exact skepticism, which is why they used a really robust triangulation method. They locked down the data using 3 independent estimates.
Okay, so it wasn't just a guess.
No, not at all. The first is a tool-based estimate. They combed through the session logs and classified every single mechanical action into 2 buckets: search actions and do actions.
Meaning they separated the research phase from the actual execution phase.
Correct. So search actions were basic lookups, stuff the old assistant could handle easily. They didn't assign any manual human time for those.
Okay.
But the do actions were pure execution, writing a specific block of code, executing a script, formatting a chart. They assigned a conservative standard time for how long an experienced professional would take to physically type and click through those specific do actions.
So that establishes a baseline for pure mechanical keyboard time. What was the second estimate?
The second was an LLM-based estimate. They fed the entire unvarnished query log into a large language model and asked it to analyze the complexity and steps. Then the LLM estimated the total time a skilled professional would need to manually execute that whole sequence from scratch.
Very cool. And the third estimate?
The third is the human reality check. They did interviews with 25 highly active computer users across various industries. They walked them through their actual logs and asked, what was your workflow for this before you had this agent, and how many hours did it take you?
But what did the users say?
They reported a median speed up of 25 times.
A 25-time speed up from the people actually doing the job.
Yeah.
But okay, let's play devil's advocate here for a second.
Sure.
Let's assume the wage data is too generalized, the LLM overestimates human sluggishness, and the users are just exaggerating. What if the researchers' baseline for human speed is completely wrong?
Well, they ran a break-even robustness analysis to test that exact vulnerability. They basically asked, how incredibly fast would a human have to work to make the old search plus human workflow cost the same as the new computer workflow?
Oh, that's clever. And the math.
The math shows that a human would need to finish every single manual execution step in about 14 to 24 minutes to break even.
Which is physically impossible for a task that involves reading docs, writing hundreds of lines of code, and testing it.
Exactly. They concluded that even if they wildly overestimated manual time by a factor of 8, computer still wins across every single domain. The margins are just so massive that standard errors in estimation don't change the conclusion.
So the efficiency gains are undeniable. But human behavior in the face of efficiency is fascinating. Because when you give people a tool that makes their output 94% cheaper and 87% faster, they don't just do their normal routine tasks quicker and then clock out at 11 a.m.
No, they immediately attempt to expand their utility.
Right. Which brings us to the final major section of this study, expanding the frontier. The data shows this happening in two distinct directions: horizontally across disciplines and vertically in cognitive complexity.
Yeah, the horizontal shift is the clearest metric of how roles are blurring now. The data reveals that with computer, users are actively working outside their primary occupation 59% of the time.
Wow, compared to what before?
Compared to 50% with the traditional search tool.
So they're stepping out of their designated lanes way more.
And stepping into highly specialized territory. The biggest cross-domain jumps are into management, digital technology, and arts and design. When an agent removes the friction of execution, you stop staying in your silo. You start doing the work of adjacent departments because the AI gives you the technical fluency to pull it off.
That makes total sense.
Yeah.
And the vertical shift shows they aren't just doing lateral work, they're doing harder work.
Significantly harder. The study maps the queries against Bloom's revised taxonomy, which is a framework that categorizes cognitive complexity. The lowest tier is, remember, just recalling facts.
Right.
The highest tier is create synthesizing info to produce entirely new original work.
So pulling a Q3 earnings report is a remember task, but taking that report, cross-referencing it with competitor filings, and generating an interactive dashboard, that's a create task.
Perfect example. With the old search assistant, tasks were heavily concentrated at the bottom. But with computer, 50% of all queries are top-tier create-level tasks.
50%?
Yeah, compared to just 26% for... the cognitive ambition of the user basically doubles.
Because the machine can handle the synthesis now.
Exactly. And they also measure this using ONET knowledge domains. That's a standard occupational database. The data shows computer tasks require 38% more distinct knowledge domains than search tasks.
Wow.
A typical workflow now demands real expertise in 2 or 3 completely distinct areas at the exact same time.
And there's a statistic here that I think perfectly encapsulates this whole transition. 38% of computer queries involve tasks the user never even attempted with the old search assistant.
Right. More than a third of the work being done is entirely net new capability for the user, and it's heavily concentrated in software dev, web dev, and data visualization.
So what does this all mean? Let's ground this for you listening in a real-world scenario. Imagine you're a marketing manager. Under the old paradigm, you'd use AI to brainstorm some copy, maybe outline an email. You're still fundamentally doing a marketer's job, just a little faster.
Right.
But with this new agent system, you aren't just writing the copy. You prompt the agent, and it writes the copy, codes a custom landing page, generates complex data visualizations to track engagement, and connects the API to your CRM database. You're simultaneously doing the IT department's job, the graphic designer's job, and the data analyst's job.
Because the bottleneck of knowledge work has fundamentally relocated. For the last 30 years, the bottleneck was your personal ability to execute. It was your ability to navigate Photoshop or write Python or format an Excel pivot table.
Exactly.
That mechanical bottleneck is dissolving. The new bottleneck is your ability to specify clear goals, supply the right strategic context, and supervise the machine's output.
Which requires an entirely different cognitive muscle.
It does. And the study uncovered a really counterintuitive data point about how users actually develop that muscle.
Yeah.
You might assume that because computer is doing all the heavy lifting, users would stop using the traditional search assistant.
Right. Why would I use the research tool if the agent does the work?
But the adoption of computer actually increases a user's search usage by 1.05 queries per day.
Oh, wow. Why is that?
Because the scope of your ambition has totally outpaced your foundational knowledge. You're tackling massive cross-disciplinary projects now, and you suddenly realize you need to research the context just to know what to tell the agent to do. If you, the marketer, are suddenly deploying a web app, you have to use search to understand basic architectural concepts of web apps so you can properly evaluate the code your agent is writing.
That is a brilliant dynamic.
Yeah.
You have to learn how to manage the machines, so you use the machine's research tool to figure out what commands to give the machine's execution tool. It's this closed-loop system of capability expansion.
Exactly. It forces you to elevate your strategic understanding to maintain your supervisory role.
Man, we have covered a tremendous amount of ground today. Let's pull these threads together. We're witnessing a historic pivot in the labor market, mapped out in empirical detail. The era of the operator is giving way to the era of the supervisor.
Absolutely.
AI agents like Perplexity's computer aren't just saving marginal minutes on mundane tasks anymore. They're taking grueling multi-hour projects and compressing them into minutes. They're driving execution costs down by over 90%. But most importantly, they are shattering occupational silos, allowing a single person to bundle roles and execute at a level of cognitive complexity that previously required a whole cross-functional team.
And this profound shift raises an urgent question about the future architecture of our workforce. I mean, if AI agents are now autonomously handling the execution of all this intermediate and detailed work-writing boilerplate code, drafting initial designs, compiling spreadsheets.
Which is the exact kind of routine friction that junior employees traditionally grind through to learn the ropes.
That's the crux of the issue right there. What happens to the concept of the entry-level job? If the machines are doing all the hands-on practice today, how will the supervisors of tomorrow build their foundational expertise?
That's a great point.
You can't effectively manage a team, even a team of autonomous AI agents, if you don't fundamentally understand what good looks like in the work they're producing. If the apprentice-level work is totally automated, how do we train the next generation of experts to recognize the nuances of the craft?
That is a heavy but really necessary thought to leave on for you guys. If the sous chef is doing all the chopping, all the sautéing, and all the cooking from day one, how does the next generation ever learn how to taste the sauce and know what's missing?
Exactly.
Navigating that paradox is going to be the defining challenge for every industry in this new era of knowledge work. Thank you for joining us on this deep dive.